Exercise 14. Use VS Code for this exercise and name the file craps_14.py. So we're going to use VS Code. This is a little bit more of a formal exercise. Let's see what it says. It's possible to simulate playing craps until a certain criteria is met. Continually play the game of craps until the balance has doubled or until the player is out of money. Use the code from this chapter, but modify it so that there is a starting balance and a bet for every round played. Remove the print statements and update the balance at the end of each round. Keep track of the number of rounds played and print this number out with the ending balance. So we coded up a single round of craps. We either win or lose that round. So what we're going to do is we're going to start off with some amount of money, say, $1,000. We'll bet $10 each round, and if we double our money, go win all the way up to 2,000, then we will stop playing. If we go to 0, then we will stop. Okay, so that is what we're going to code. And let's flip over to VS Code and go ahead and open up the craps file that we already created. Copy the code and then click on module 9 and then the new file. And we're going to create a new file called craps_14.py. We're going to paste this code in here. So this represents one round of the game. We either win or lose. What we want to do is continually play the game until we either lose all of our money, go to 0, or double it. So let's go ahead and at the top here, we will create a variable called balance. This will be our starting balance. And we can make it $1,000. And then we will have a bet size. So every round, this is what is bet every round. We can make it, let's make it 20 so it won't take as long. All right, so that is that. And we need to keep playing until the balance is either doubled or we've gone down to 0. So let's write, this needs a while loop. So we're going to keep playing this game. So while the balance is, I guess you could say, not in 0 or double the balance. So we can actually just programmatically do it like this. So while it's not 0 or not the balance times 2, we will have all of this. We're going to keep playing the game. So I need to put all of this in the body of the loop. I'm going to press tab like that. Tab it over, and let me remove that line. So now it's going to keep doing this. Now we have to change the balance. So if we've won, we are now going to change the balance. We're going to add it to the balance. If we lose, we're going to subtract our bet. So everywhere we have a loss, so right here in stage 1, if we lose, we're going to say balance minus equals bet. So we're going to lose our bet. If we win, we're going to say plus equals our bet. And we're not going to print anymore, so let's get rid of that. All right, so in stage 2, this is a win. And we're not going to have any print statements, or else we have too many print statements. So that was a win. So we'll say balance plus equals bet. And for this, we'll have balance minus equals bet. Otherwise, yeah, continue rolling. We're not even going to print out a message for that. So at the very end, so when it reaches 0 or double the balance, we'll print out. Oh, actually, we need to have a variable to count how many times we've played. So let's call it rounds. And for every round, we will just add 1. So we're going to say print you played rounds of craps. Your balance is at balance. Okay, so we could have a if statement saying if we got to 0, we lost all our money, or we doubled all our money, but this is good enough. Okay, so let's take a look again at our code. We're going to start off with some amount of money. We're going to have some bet size. The rounds will be at 0. So we're going to keep playing the game until our balance is either 0 or double the balance, and then the rest of the game should hold like before. Actually, let's get rid of this print statement. There'll be too many print statements. We get our first roll, and then all the stages are the same. What we've changed here is when we've won or lost, we've just either subtracted our bet from our balance or just added our bet to our balance. Okay, so let's see how this works. And now we'll do Python craps14.py. Let's go ahead and run this. And okay, it says we have an error over here. So it says unsupported operand types, built-in function rounds, and not round, I forgot an S over here. So it tells you what line it's in, line number 9. So there's the line number over here. That's where the error was. And now let's run it again. So you played 9,226. That's a lot of rounds of craps. We could make this go by faster, say a bet size of 50. So we'll change that. So we'll either double our money faster or lose it all faster. So we lost this time. So we got down to 0. Let's keep going until we get a win. All right, so we played 648, I should say, rounds. And let's do another one. Played 432 rounds of craps. Our balance is 0. 88-0. Let's see if we can win. Looks like we're going to lose. Doesn't look good. All right, can we ever win? All right, let's change one thing. Instead of saying 100, let's bet 200. So hopefully this will give us a better chances of just winning and quitting. The reason we're losing so much is that you're more likely to lose in craps than win. So if you play the game long enough, you will lose all of your money. It is a casino game after all. It's not, the probabilities are not in your favor. It's like 51% to 49% for each round. But the issue here is that if you play a lot, that 1% edge that the casino has does add up a lot. Okay, so I changed now the bet to 200. Let's see if we can win at craps here. And we're going to just keep playing until we win. Or maybe there's a bug in our code and we are just never going to win. All right, after pausing the video, I figured out that I did have a bug in the code and we were never going to win. So balance can never be balance times 2, right? That doesn't make any sense whatsoever. So how can it be twice itself unless it's 0? So that's why it was never winning. So I need to change this, and this is, I'm going to use different logic over here. So this is common in programming. You write one piece of logic. It looks like it works, and it may work for some things, but it doesn't work for all of the things. What I'm going to do here is I'm going to use a chain comparison. This will actually be a more robust solution. And not greater than or equal to. We'll say, I could have some, I could say the target we want to get to, just in case I want to change this. So balance times 2. All right, so this says while the balance is between 0 and the target, right? So as long as it's, $1 all the way up to whatever balance times 2 is. Now this will be pre-calculated, so it won't change, right? So this will be set at 2,000 right away. And now I'm going to make my bet. Let me put it back to, say, $50 and make sure I save this. So you notice that a little dot is gone after I save it. And now I should have some wins over here. And so I was debugging with a print statement. So here you can see my print. I was printing out the balance. And I was saying, oh, I was actually going way above my double of the balance. That's how I figured it out. So a way to debug, one way is just to print out what is happening. Let me go ahead and, actually we can keep it in. Let me change the bet to 100 so I get more quickly to either the target or to 0. So let me go down here. So this is just printing out the entire way, the entire path that I took. Okay, so it's a lot. So I started out at 1,000. I had a little winning streak over here. I didn't quite get to 2,000, as you can see here. Then I had a losing streak, looks like, and then back, maybe a lot of back and forth. Finally, a big losing streak. And then we finally reached 0 after 112 rounds. Okay, let's see if we can win one. This one after 94 rounds. All right, finally, we win. All right, we made it to 2,000, and then we stopped. So that's what we wanted to do. This is after 34 rounds. Let's go ahead and take a look at it. So we go from 900. We lost our first one, and then we had a little winning streak. We hovered around here, some up and down, and finally had a nice little winning streak at the end to reach to 2,000. All right, so this is common in programming, so it's good that you saw some, some logic, some errors in my logic, and which we figured out using print statements. And now we can sort of get rid of this print over here and save it. So that's how you do number 14, where you play until you either double your money or you lose all of it.